Question 11 says if pressure P, length L and acceleration due to gravity are chosen as fundamental units, then the dimensional formula of velocity is. Now dear student, let us write down the dimensional formula of velocity will be P to the power A, L to the power B and G to the power C. Now let us write down the dimensions of left hand side and the right hand side. On the left hand side the dimension will be LT minus 1. On the right hand side the dimensions will be ML minus 1, T minus 2 to the power A. These are the dimensions of pressure. The dimension of length remains as L only and the dimension of G will be LT minus 2 to the power C. So this will be LT minus 1 is equal to MA L minus A plus B plus C T minus 2A minus 2C. Now as we can compare from both sides, the dimension of mass on left hand side is 0, so this means A should be equal to 0. Also we can write down that minus A plus B plus C should be equal to 1 as we compare the dimension of L. And as we compare the dimensions of T, we can write down minus 2A minus 2C is equal to minus 1. On solving these three equations, we write down A to be equal to 0, B to be equal to half and C to be equal to half. Meaning that the velocity or the speed can be written as P to the power 0, L to the power half, G to the power half. And hence the correct answer for this question is option number 1. Now let us move to the next question. In the next question, the acceleration of a moving object is given by, it is given that A is equal to Ct plus Bt square, where T is time dimensions of C cross B has to be calculated. Now to student, the dimension of Ct should be equal to A and the dimensions of Bt should also be equal to A as from the principle of homogeneity. So we can write down that Ct should be equal to Lt minus 2, that is the dimension of acceleration. So C will have a dimension of Lt to the power minus 3. Similarly, the dimensions of Bt2 will be equal to Lt minus 2, meaning that the B has a dimension of Lt minus 4. From this we can write down that C cross B will be equal to Lt minus 3 multiplied by Lt minus 4, and this the student will give us a value of L2 T minus 7, and as we can see from the given option, the correct answer should be option number 3. Now let us move to the question number 13. In this question, at the maximum height of a body thrown vertically upwards, the velocity is not 0 but acceleration is 0. Acceleration is not 0 but velocity is 0. Both acceleration and velocity are 0. Both acceleration and velocity are non-zero. So we have to write down whether the acceleration is 0 or the velocity is 0. Dear student, as the particle moves, at the topmost point, the velocity of the particle becomes 0, that is instantaneously it comes to rest. However, during the whole journey, there is a downward acceleration which is equal to g, which is also the acceleration due to gravity. And hence, dear student, the correct answer for this question should be option 2, that is acceleration is not 0 but velocity is 0. Now let us move to the question number 14. Question 14 says the change in velocity of a moving body can be found from. The student, acceleration is defined as the rate of change of velocity, that is dv by dt. From this we can write down that dv is equal to a dt, and further on we can integrate on both the sides. The left hand side is actually the change in velocity, while the right hand side is the area of acceleration time graph, and hence we can clearly see that the area of the acceleration time graph leads to the change in velocity, meaning that the correct answer for this question, dear student, should be option number 2. Now let us proceed to the next question, which is question number 15. In this question, if a ball thrown vertically upwards with velocity 40 meters per second, the distance covered during the last second of its descent is something that we have to calculate. Dear student, as the ball moves up, it reaches the maximum height, and from there it falls vertically downwards. We have to find out the distance traveled in the last second of its motion. Now for this, let us only study the downward, that is the descent motion. For the descent motion, the velocity at the topmost point is 0. We'll use this. Now let us also try to find out the time taken for the body to reach the bottom from the top. That time is equal to the half of time of light, that is u by g, and this will be equal to 40 by 10, and that is 4 seconds. So essentially we have to find out the distance traveled in 4 seconds, that is 4th second in the downward motion. We can use the equation that Sn, that is the distance in the nth second, is equal to u plus half a 2n minus 1. Here u is 0 from the downward motion concept. The initial velocity will be 0, that is at the topmost point. So this will be 0 plus half. A is taken to be 10, that is g. 2 into 4 minus 1. This gives us a value of 35 meters. And hence for this question the correct answer turns out to be option number 3. I hope you understood this question. Now let us move to the question number 16.